Okay, so my name is Blewett, and I'm going to be talking for the next sort of hour and a quarter, hour and a half about introducing unit tests into legacy code. Now, I know you're thinking, what's the point of this? Everybody always does greenfield projects. We don't have legacy code. There's no need to worry about that. The problem is, most of the time when you look at presentations on unit testing, there's an assumption that you're starting from a blank sheet of paper because you're doing test-driven development, which is great. It's a brilliant place to be if you can get there. But unfortunately, almost everybody, when they first approach, think, I understand the value of unit testing, and I want to introduce it, but I have this huge code base that we already have that doesn't have unit tests. How do I bridge those two worlds of wanting unit tests, but having a world that doesn't actually have them at the moment? And that's really what I'm going to talk about. Now, a lot of the things, or a lot of the general stuff I'm going to talk about is technology independent, but I'm going to talk about tooling, and I'm going to talk about techniques, some of which are .NET specific. Okay, so if anyone is not remotely from a .NET background, I can't remember whether the abstract was explicit about this, but I am going to talk about some .NET specific stuff. But there are some general sort of lessons here for introducing unit testing to legacy code anyway. Okay, so I'm going to cover a few bits and pieces here. First of all, just, why is there a problem about unit testing legacy code? We're going to talk about the concept of abstraction, about making sure you don't break everything when you're trying to introduce unit testing, which is more than like I break functionality, that I don't have to change all the code when I introduce it. There's a few things that people may sort of argue about whether this is a good thing, about how introducing extra functionality that helps you test, even though it's not actually necessary for the functional execution of the program. A couple of different techniques for trying to get around awkward code that you just can't get rid of in any other way. And finally, we'll talk about this concept of shimming, which you require a fairly invasive toolkit to do, but sometimes there's no other way. Microsoft have a toolkit called Microsoft Fakes that allows you to do it, and there's also a product called TypeMock which allows you to do it. But if all else fails, there are ways of essentially rewriting your IL at runtime to allow you to test stuff, which we'll talk about at the end. Okay. So, in terms of questions, if you have questions, please stick your hand up. Because it's been recorded, I will endeavour to repeat the question. If I don't, shout at me and tell me to repeat the question, because I might forget. Okay, so pretty much everybody is in a situation where they have an existing code base. Very few people walk into some form of development with no heritage code. Is probably a very polite way to call it, isn't it? A bunch of code that's already there that doesn't necessarily have unit tests. And you can introduce new code that has unit tests and leave the other stuff alone. But generally, I'm assuming everybody here has at least some sort of like reason that they want to introduce unit tests to legacy code. I'm not going to sit here and try and sell why unit tests is a good idea. I'm assuming people already have the are there in that space already, that they think that unit testing would be a desirable thing, even though they're not necessarily sure how to put it into their existing code base. The problem is that when you write code and you haven't got unit testing in mind, you generally write code in such a way that makes it very hard to introduce unit testing, because test-driven development, unit testing in general, enforces a certain discipline on the way you write code. Generally, that discipline is a very positive thing because it means your code is generally very loosely coupled. However, it doesn't come naturally. It's something you have to enforce into your code base, and test-driven development pushes you in that direction naturally. But if you're not doing unit testing, you are unlikely to have done that off your own volition automatically. Okay? So you have to design code to make it testable. And there are certain things that end up in code that make it very hard to unit test. Remember, unit testing is about isolating the system under test, the SUT, the S-U-T, system under test. We want to isolate it as a single unit so we can test it in isolation. So when you have hardwired dependencies, you go and create an instance of something directly, you are bound to that type. Okay? There's no way to replace it. You are physically bound to that specific implementation at that point, which means you can't isolate the thing that is using it. Singletons, there's whole talks that people give on why singletons are evil and stuff like that, but sometimes they are kind of useful. But the point is, once you have a singleton, you have something which makes it potentially very hard to unit test, because again, you have a single implementation out there that you're having to use. Static methods. Again, you see lots of situations where statics are used in terms of implementation. They can be sort of lovely thing. I love extension methods, which are static methods. But again, unit testing those code that uses them has a hardwired dependency to the type that that static is based on. Okay? So these sorts of things make it very hard. These are naturally very often in legacy code, but are a barrier to introducing unit test. So generally what we need to do is to refactor the code in some way such that we don't have these. Okay? The idea of refactoring, yeah, I hope people are familiar with that. We change the code in form, but not functionality. That's the idea of refactoring. Yeah? But we have a problem here. Okay? So I need to introduce some tests into my code. I need to refactor my code to introduce the tests. To refactor safely, to make sure I haven't changed functionality, I need tests in place, which means I need to introduce tests into my code. We have essentially a circular problem that how on earth do you start here? Because you can't change the code safely without having tests, but you can't test the code without changing it. Okay? And this is the real issue with legacy code. So what we're going to really talk about here is how can you start to introduce tests in such a way that you minimize the likelihood you're going to break things? And inevitably, you will change things such that it has some level of cascading effect eventually. But the main issue is you have to start somewhere. And how do you get started? And how do you start to increase the velocity that you increase tests with over time? Because it will be a slow process initially. OK. So getting started is potentially a very daunting prospect. You have this big code base. Where do you start leveraging out bits of code to introduce tests into? So you're likely, your code base is potentially very large. You'll certainly, any reasonable to have lots of lines of code. I must say, I think you may well have many classes. More worryingly, you may have very few classes and very large numbers of lines of code. But you all likely have lots of classes. You have lots of stuff that you've got to test. And most of it was probably built without the need to do testing in mind in the first place. Now, unit tests, again, are about isolating the system under test, so you test that one unit and only that unit. It obviously isn't the only form of testing that's important. You have a bunch of different components that you have to test working in concert because a whole number of other sort of set of issues that can arise once you start plugging the things that all seem to be working in isolation together. You put them together, the way they interact may cause issues. Okay? And that's generally called integration testing. Now, if you already have integration tests across your application, but you don't have unit tests, then you're already in a much more positive place than you otherwise would be, because at least you have some level of guarantee that stuff is still working. Now, integration tests, because they generally hit network resources or the file system or databases, are things that aren't incredibly fast to run. One of the goals of unit tests is having a set of sort of assurance tests that are very fast to run, so you can run them over and over and over again without causing issues. Okay? With integration tests, generally, one of our products, we've got a set of tests that test the various interaction with unpacking various zip files and stuff like that. And individually, those tests take like 20 seconds each. And so we really don't want to run them on every build. It's very annoying when you press Control-Shift-B to do a build, and then you have to wait 5 minutes for the test suite to run. Okay? You want the test to run very quickly. So integration tests typically don't run really quickly because they're testing stuff that is outside of memory. Okay? So it's a great place to be because you have some level of assurance when you change things, you haven't broken anything, but it's not enough if you're talking about automated testing and making sure it's part of your sort of general sort of development cycle where you build, test, so it compiles, and all your tests will pass is something you have assurance that you make changes. The first thing really, to clear the decks, is that inevitably there will be code in your code base, once it's been around for a while, which is commented out. And the most scary thing is when you go to a code base for the first time you've never touched before, and you find commented out code, without a comment above it saying why it's commented out, you're thinking, I wonder what's going on here. And it may be someone checked in thinking, I will temporarily take that out and I'll put it back in shortly because I just can't use that particular bit at the moment. It may well be that. It may be that we don't need this, probably, but we might. I might be wrong, so I won't actually delete the code. When you're trying to introduce unit tests, the last thing you want is huge amounts of cruft in your code that isn't used. It's either commented out, or it's methods that aren't used, or it's sections of code that are unreachable. But essentially, you don't want to be writing tests for stuff that aren't actually going to be used in the application. And you want as clean a code base as possible to start with, because anything that masks what's actually going on in the code makes it harder to introduce unit tests into that code. So, go through the code, delete commented out code, delete unused methods, delete unused variables, because I hope you've all got a version control system. You can always bring it back if you think, oh, actually, that was really important, the bit I've just removed. Does anyone not run with a version control system? Back in about 1995, I was working on a project where they decided version control system was too expensive, so I had to be the version control system. All changes went through me, and I had to merge them onto the code base. It was a very scary experience. Yeah, so version control systems, if you haven't got one, please get one. But obviously, once you change stuff, you can always revert back if you cause a problem. But the last thing you want to do is end up in a situation where no, I won't do that. So, for example, you can imagine walking up to this bit of code here and again, well, there's obviously a whole bunch of things that are important in here. There's some code here. Fortunately, IDEs generally highlight bits of code that are commented these days, unless you're developing in Notepad or something. There's a whole bunch of code here. Now, it may be that someone has temporarily thought, well, this functionality isn't working here, this verification of existing products, so I'll comment that out for now. But it may be that they realized at some point that we probably didn't need to do that, but we're too scared to press the delete key. Okay? So first thing, as I said, if you're going to introduce unit testing, is go through and essentially clean the code up. So, which obviously makes it a bit easier to understand what's going on at that point, just through reading the code. But it's also, if you're using a product like ReSharper or something like that, you get other hints. This nice grayed out method here. Okay? This basically means as far as ReSharper is concerned, no one is using this method. So what do you need to do at that point? Delete it. There's no point in having methods there that no one's calling. Again, you have a version control system if you shouldn't have done that, I hope. Now, particularly this word here, internal, private or internal, means it's limited who is able to call this method. Okay? If it's public, then as a class library, you don't necessarily know who might be using the method, in what circumstance. But internal, they've got to be in the same assembly. So in theory, if no one in this assembly is using this method, then no one's using this method. Okay? So, again, ReSharper can be a wonderful thing. If I go to find usages, and it comes up and says, the usages were not found, it's internal, no one's using that method. Okay, so again, delete it. Okay? Because suddenly, what was potentially, okay, I know wasn't a huge amount of code. I haven't got a huge legacy system to bring today and spend 5 hours trying to refactor it. But the amount of code we're now looking at in terms of introduced testing is tiny compared to what it was. Okay? So it gets to the point where you know exactly what you need to test by getting rid of all the stuff that isn't actually being used in the application. Okay. The other thing is, the compiler is a great tool. When you delete stuff, the compiler will tell you if someone was using it, okay, inside your application. Even though it didn't look like anyone was, the compiler will shout out very quickly that this thing is gone and I was expecting it to be there, okay? So rely on the compiler as part of your refactoring technique as well. It can be tempting. You can get into that groove of saying, I know how to change this code. I know how to make it testable. And so you'll go through and do huge amounts of stuff in one go. And you'll make changes and go, oh, hold on, I need to change that now because that was used. And so you make changes over here. And I'm testing this bit. And you end up making loads of changes. The problem is the likelihood that you've broken something magnifies hugely as the more the effect cascades if you're trying to introduce tests. The main thing is to try and start somewhere and try and start somewhere very small. And then work outwards from there to introduce tests. You try and do a big bang, everything will break, almost certainly. You would have changed huge amounts of behavior inadvertently. All the edge cases that you've forgotten about will no longer work and that sort of thing, okay? And it does mean that it's a slow job initially. It's a very tentative job initially to start introducing tests. But again, you have to start somewhere. And the point is, as you get more test code coverage, the faster you can start to introduce things because the less likely it is you've broken things. You know when you break things. Okay. Code coverage tools, there's one built to Visual Studio, there's a whole bunch of other sort of code coverage tools out there as well. They're a great thing in terms of giving you indicators about how far you've come in terms of your legacy code base. It's very tempting to get drawn into this siren call of the code coverage statistics, though. In of themselves, code coverage means nothing. Okay? Just because you have code being executed as part of a test doesn't mean you're actually testing the code. It just means the test is running through that bit of code. It doesn't mean you're testing the logic of it. Okay? So it's not an end within itself, but it is a useful indicator to say, as you introduce tests, how far you've actually got to. So as a metric, it's useful, but it's not the deciding factor. High-quality tests are more important than the fact all the code has been executed. Okay? Okay, so where to start? What do you initially need to do? Well, fundamentally, most of your code will do one of two things. It will either touch a resource that is physical in some way, so it goes to the config file directly. It talks to the database directly. Okay? At some point in your code base, you hit the metal. Yeah, you have to. Otherwise your code doesn't actually do anything. Yeah. The other thing your code may do is use things that hit the metal. Okay. Almost certainly, somebody is actually running against real physical resources somewhere. So those things themselves are very hard to unit test. And we'll talk more about this at the end, about maybe how you can even introduce tests on things that are directly hitting the metal there. But once we go back a layer, we have code that is using the things that hit the metal. And that's where we want to start introducing unit tests initially. Okay? The problem is because they have potentially a hardwired dependency against the thing that talks to the database, I can't test them in isolation. So how do I start breaking that dependency? So there is a fantastic refactor, not just in ReSharper, but in Visual Studio natively, called Extract Interface. And the great thing is, it's free. In other words, you can do it and you're not going to break anything at all. Okay? It doesn't have a cascading impact. If you add a parameter onto a method, that's going to break somebody. Okay? But by simply extracting and creating an abstraction about something, you don't break anybody. but you give yourself the opportunity potentially to start unwiring things, okay? So, let's go to, I've got this product repository, which formally talks to a database. It doesn't actually talk to a database in this situation, but formally talks to a database. And I've got this sales summary here, which is using the product repository. The problem with the sales summary is I can't unit test it. Because if the product repository is talking to the database, then this class is talking to the database because of that keyword. Okay? It creates an instance of the product repository, therefore, there is absolutely no way for me to unit test this code, okay, in isolation. This code will indirectly talk to the database, okay? So how do we go about changing this? Because I'd like to introduce some unit tests onto this. So I can go to the product repository, and the first thing I can do is go to refactor and say extract an interface. I'll say this is ReSharper's version, but there's Visual Studio has this built in as well. Okay? And then I say what I want on there, and I'll have all the methods on there. Okay, and it creates me an interface. Now that in itself doesn't solve anything at all. But I haven't broken anything, so I should be able to compile quite happily still. Everything works. I should be able to run the application quite happily. Yep, application still works happily, okay? What it now allows me to do is go to the code that uses this type and start working in the form of the abstraction. So I can go back to the sales summary and do that, okay? Now, again, it compiles okay, it runs okay. I haven't solved anything yet, but at least now, apart from this line of code, everything is working in terms of the abstraction, okay? My next goal is to get rid of that thing, okay? Because once I get rid of that, I can unit test, okay? So, what I'm going to do is use dependency injection. I'll just inject it in the constructor, okay? Standard sort of thing. So let's so we can okay. So now we've got a. So does anyone? Does anyone not use something like ReSharper or I think DevExpress or CodeRush and stuff like that? Anyone not use any of those tools if they're on .NET based? Is anyone not doing .NET based code at all here? Okay. So I said lots of IDE, I think like IntelliJ and stuff like that has similar kind of functionality available to it. But if you're not using code that can do things like, write code for you, like that, it's you're harming your own productivity, I think. Certainly recommend it. Okay, so so here now we're injecting it, which is great because it means I can pass an alternate version of this that doesn't talk to the database now. I can use a stubbed out version or something like that. I've got a problem now though, haven't I? My code doesn't compile anymore. So you go, okay, so now what I need to do, everywhere I use the class, I have to go now, create an instance before and pass it in. And suddenly, we start getting cascading changes. And suddenly, the scope of what I'm doing starts breaking horribly, and now I need to start sort of potentially, this big bang starts to unfurl in front of my eyes, okay? So, this is necessary to introduce unit testing, but we have to do more than that if we're actually going to have sanity in legacy code. So we can inject the dependencies, and it certainly, as I said, gives us the ability to unit test that particular piece in isolation, but nothing's compiling anymore. So what do we do? The primary concern with legacy code is to make sure you don't change the public API while you're introducing the ability to inject dependencies and that sort of thing. Okay? So we can happily create ourselves in here a default constructor which injects the dependency automatically with the concrete type. We still have this one available, so we can actually unit test, but we maintain the public API so everything still carries on working as it did before. Okay? Okay, so now everything compiles again, and it all runs as before. Now the point is now I have the ability to start injecting a different version of this so I can start unit testing the code without touching the database. Okay? All right then. Now, that's all very well, but sometimes we have to unit test things that only make internal changes to a class, but those internal changes are very significant for other stuff that happens later on. And when we're trying to isolate the effects and test the specific effects of functionality, sometimes those internal changes are important. So how do we gain insight into what's actually going on inside? Well, first of all, here we have a piece of code, okay, that changes some internal variable by calculating interest. It doesn't return what that is. Okay. There's things we could do. We could change this such that it does return the amount. That's not going to break anybody who's expecting void, okay, which means I could test it. But it does change the method signature, which may be significant. And obviously, if it already returns something else, then that would be a problem. We couldn't just return it. We couldn't add an out parameter without breaking other code that was using it. So what we can do, whoops, is just add a method there that shows us. So we can basically call this and then assert on this line of code, basically verify that the effect we were expecting has happened. Okay? Then go, oh, this is changing the public API. I don't like that. Because it's new functionality that rogue developers can start calling sort of at any time they wanted to. You could make it internal. And then people familiar, .NET-based, the internals visible to attribute, where you can basically say the test project can see the internals. So you could make it internal. But adding extra functionality that's there for testing, if you're trying to unit test stuff, it's really important to make sure that you have visibility of the effects. And again, we'll see in a second, it's hugely important when you're talking about asynchronous code. The important thing is to remember, the goal is to break the dependencies, though. So eventually, everyone using the class is going to be using the interface, or the abstract base class, whatever you choose to use as the abstraction. As long as you don't put that new method on the abstraction, then it actually isn't really part of the public API of the class. Okay? As long as everybody's using the abstraction. In fact, the only code that is really going to be using you is either internally, essentially inside your version of control container, or the code that does the initial wire up of the application, whether you're using IOC container or not, or your test code. That's the only thing that's actually going to see the physical public members of the class. Nobody else is really going to see it, because everything else should be written to abstraction over time. So adding extra members, as long as they don't become part of the actual abstraction, isn't really that big a deal, in my opinion, anyway.
Somebody might say that adding the extra method makes your test more brittle because you're now unable to, you have to worry about if you change the internal representation of the data or whatever that method's going to break and so on. So how do you sort of factor that into your consideration?
Okay, so question is that potentially adding extra functionality gives insight into internals, makes your tests potentially more brittle. Okay, is that? Yep. Okay, so certainly, yeah. I mean, because you're now exposing an internal part, then potentially it limits your ability to change the internal part without affecting the test. Absolutely. But then again, if you need to introduce tests, there's a tension there, but how do you go about introducing tests that verify that behavior has worked correctly? And there certainly is a tension there, because ideally, that method would return the interest that it calculated, and at that point, I wouldn't have an issue, okay? But I'm in a rock and a hard place here. I have to verify it did the right thing, but you're right. I potentially exposed the test to things that otherwise would have been purely internal changes and break later on. I changed the type of, I decide to hold the interest rate as a string rather than for some bizarre reason. I would break the test. I would break the code, absolutely. Yeah, and you're right, there is a tension there. And there are always, when you're introducing unit test legacy code, there are going to be a bunch of trade-offs that you have to make along the way. It's not, this stuff wasn't designed to be testable, so therefore you have to try and leverage it to be testable. And maybe over time you can remove those extra methods you had to add as a result. But when you first start, you have to be able to potentially gain insight into things that aren't visible naturally. Okay? Okay, now, this is particularly important with asynchronous code. If you've got code that runs asynchronously, irrespective of legacy code, it's really, really hard to unit test. Because you have some code that spins off another thread and goes and does some stuff in the background. And it probably, the method you call, isn't going to then wait for it to finish, because that's not generally the point of doing stuff asynchronously. So the question is, when you write your test, how do you verify the asynchronous thing actually happened correctly? Now, in .NET 4, they introduced a thing called task. And a task is a nice abstraction over asynchronous stuff, okay? And when you're running stuff asynchronously, it's really handy to know when it finishes, you can verify the results in your tests, okay? The problem is, how do you know when it's finished? So adding a member of type task that represents when that asynchronous thing is finished is one way to do that. So your unit test can basically wait on the task that represents the asynchronous bit of work, and then once it's finished, can verify the outcome. Okay? Now, most code won't be using that member that indicates, only your test code will be using it. Okay? But it's the only way to, it's one of the only ways, there are a couple of other ways to do it, of testing asynchronous code. Okay? You have to know when the asynchronous stuff is finished. Otherwise, you can't verify the outcome. Okay? So there's a class called task completion source that allows you to essentially create a task over any arbitrary thing that's happening asynchronously. It doesn't have to be another thread. It just can be anything that's potentially happening asynchronously. Okay? But certainly, if you've got asynchronous things happening on your legacy code base, introducing things of type task is a very powerful way to start introducing unit tests to verify the asynchronous behavior. Okay. Sometimes we have bits of code that talk to hardwired dependencies stuck in the middle of code. Maybe it's here we have some code up here, we have some code up there. Then we go and create a WCF proxy or something, a web service proxy that we then call, and it goes and gets some stuff. This is going to hit the network. It's also using a static member, which means we can't inject our own version of what time the current time is. It just basically ends up as a real pain to work with this particular sort of code. So how do we go about dealing with chunks of code that are just basically hard to work with? I mean, you can say, okay, what we could do, we could inject an abstraction over this proxy. And there are ways of doing certain bits, but sometimes, especially with large amounts of code, actually rewiring everything just to get a test in there becomes very, very unpleasant. Okay? So there's a few ways we can approach this. Again, the goal is not to introduce breaking changes to the code that's using this. Okay? So extract interface is one like free refactor. Another one is extract method. So basically, take a bunch of lines of code and pull them out into a separate method. Okay? It's not going to affect anybody using that code, as long as you do it correctly. Yeah? So here now, instead of all the stuff that talks to the hardwired dependencies, we basically just have another method that is used inside the method we want to test. Okay? Now, in of itself, this hasn't solved anything. Okay? This is just basically moving the code around. But it's a step. The next thing we can do is mark that method as protected and virtual. Okay? At that point, we have this really nasty bit of code here that we want to be able to test, but now it's replaceable by a derived class. Okay? So the final thing we then do is we create a class that derives from our original code that replaces the bit of code that's really hard to test. Okay? And then we can write unit test against this, knowing that apart from the nasty bit that we couldn't remove the dependency very easily from, we can basically unit test the rest of the code, the rest of the behavior. Okay? So I think I've got something that does something similar in here. Okay, so inside the order processing, for example, we have a whole bunch of stuff that's fairly gnarly in here. So, so is that the right one I wanted to do? Yeah, so essentially what we can do in here is, for example, taking that line of code, we can extract that into another method. We can mark it as protected virtual, and so it doesn't actually go off to the credit agency and do credit scoring. Quite a few years ago, 23 years ago, I was working on a client server system for a bank, and it was part of their account opening infrastructure. And as part of account opening, you needed to credit score somebody, okay? And obviously, if they, you don't necessarily want to give them a bank account or don't want to give them particular credit facilities based on their credit score. There's a problem with credit scoring, though. Credit scoring imaginary people doesn't generally end up with a very good credit score. So we were trying to test the code. So we were running a code, and the main thing is, well, I've got to use someone real here. So the most obvious real person you could use was yourself, okay? So you put your own details in, run through, and go through. Does anyone know what happens to your credit score when you get credit scored? So the entire team ended up with basically 0 credit scores by the end of about 3 months of testing this application. You're wondering why you're getting different results over time through testing it, yeah? As your credit score was plunging, as you were being credit scored like about 30 or 40 times a day. And the bank had to basically go to the credit agency and get all our records expunged at that point. So this sort of thing is really important to be able to remove. It might be that it's just, it's time consuming. It might be that it has other external effects. It might be that you have to pay every time you use that particular piece of functionality. So being able to remove it and replace it with a stubbed out version is really important. Okay, so again, if you abstract, you take the piece of code, so you can extract a method. Okay, and then we can make this protected and virtual. And at this point, we can derive a class and replace this method with something which either just doesn't go and do that expensive functionality, or potentially can, I don't know, throw exceptions if they don't pass the credit score, whatever the behavior would be if it had gone to the credit agency and failed the credit score, for example. Okay? Okay, so that's one way of doing it, and that works great for if you have just specific regions of code. But sometimes you end up with large chunks of functionality of a class are essentially untestable naturally. I think, well, having to go through and sort of do this exercise on every single bit, then I have to basically create a fairly complex test double to exercise the code in the correct way and to replace the functionality. Well, how can I maybe achieve a similar end, again, without breaking all the consumers of that code? So, extract and adapt. So the idea here is we know what the code should probably look like if we were making it completely testable. Okay? It will be injecting all the dependencies, and we could completely rewire how it works. But then the problem is, essentially, we're going to break the downstream code. Okay? So one thing you can do is refactor the code into the shape that you'd like it to be and call the class something different. Now, obviously, as we know, there's one of the biggest issues in software development is naming things. And what you name this class is always a bit of a tricky thing because it is actually the same thing, but it's a testable version. Certainly, I use the word core on here, which I wouldn't certainly not saying is my recommended naming convention. I just didn't know what else to call it. But for example, so here we have instead of product controller, we've got product controller core, which now is having the dependencies injected that allow us to do the testing. So we inject the service that was being invoked. We pass in a delegate that essentially allows us to provide what the time is. Okay? And then this method now is testable because we can inject a version of the service which doesn't talk across the network. We can inject what we consider the current time to be, or current date to be. Okay? The problem is we've completely wrecked the public API of this now. Anyone using this is just going to, it's just not going to compile. So the point about making this a different class, though, is we can essentially use the original class as an adapter to the code that's consuming. Okay? So the original class is really just hollowed out now using the extracted class and injecting the correct dependencies into it. Okay? So essentially an example of the adapter pattern being used to allow us to do testing in this case. Well, if I inject the product controller core, then the downstream code is potentially going to be broken. I'm omitting defeat, essentially, on this particular class, allowing me all the functional stuff is inside product controller core. I mean, I certainly could have another one that allowed me to inject it, just to prove that I was actually calling the core one. I could certainly do that, absolutely. But in terms of, we end up, hopefully, with all this code does is just hand off to the other code, which is fully testable. But yeah, I certainly could. I mean, there is an issue. You can say, well, when I do generate a sales report, am I passing in the correct date? There's always going to be a problem about verifying I am actually passing date time, not now in, but I would certainly could say, well, within certain tolerances, does it look like the current time? You could certainly do that, but it's there are still some issues. But yes, you could inject it. Sorry, I can't.
One must be pragmatic, otherwise you're building a complete test system into legacy code. If you were trying to amend something around features and you need to put testing in so you can amend it, you don't necessarily have the time to do testing framework.
Yeah, exactly. I mean, so you're absolutely right. Pragmatism is hugely important in terms of being able to say, well, the goal of introducing unit tests isn't because we all love unit tests. It's because we're trying to achieve an effect of having unit tests that means we can adapt code in a far more rigorous and safe way than we previously could. And if that means having to make some compromises along the way, then that's what you have to do. And I said, none of this is perfect. I mean, ideally, you never end up in this situation at all because you just rewrite everything from the ground up. Unfortunately, that's not a particularly likely scenario for most people. So if we go back to the code here, essentially what I want to do is take this stuff and rewrite it, okay, with a new class. Okay, so what have we got in here? We've got a product repository, so anything else you need to put in there? I guess we want to do that. So, oops. And all we'll do is we'll just pass in an action delegate, which is credit score. Okay? Okay, so now, if we go and look at the functionality that's in here, that's essentially what we want to reproduce. Apart from that. Okay, so that's essentially the functionality we want to reproduce. But now, we just say, we just invoke the delegate as part of it, which is the nasty bit we couldn't do. And we have the product repository here that's been injected, so we don't need that line of code now. Okay? So at this point now, this is fully testable. And then we change the calling code to, I'll comment it out. I know I said delete all the commented out code, but just so it's still there when I sort of put the demos up. So now we just do oh man, take some. Okay, so all we're doing here then is do core dot place order, customer ID, product ID, quantity, oops, price, and then we just need the action delegate that calls the credit score. So the ones are lambda expressions. Credit score, customer ID, comma, credit score. Okay. So essentially now we can happily unit test this particular class quite happily, knowing that the actual functionality is still in place above. Okay? Okay, so the problem is we're still changing code, and changing code is always a dangerous thing to do when you haven't got tests, because, again, you don't know whether you've broken things. So is there any way to introduce tests without changing the code that's been tested? Okay? The problem is, what we need to do, therefore, is whatever that code is doing, we need to change the behavior of the dependencies, magically somehow. Now, if you're working in an environment that doesn't produce native code, this is actually a reasonably possible thing to do. Because if you can change the structure of the thing in memory that it's calling, rewrite the bytecode or the IL or whatever it is, the intermediary sort of infrastructure that's been invoked is, then essentially you can change the behavior of the dependency or what it perceives as the dependency. Okay? This is the idea of shimming. There's, as I said, a couple of products out there that do it. There's a product called TypeMock, which there's two versions of TypeMock, one that's free, one that you have to pay for. The paid for version would allow you to rewrite the IL of downstream methods. Microsoft in Visual Studio 2012 introduced a thing called Microsoft Fakes. For quite a while, it was only in the Ultimate Edition, which meant nobody used it, because very few people buy the Ultimate Edition. As of Update 3, it's now in Premium as well, which means it's something worthwhile talking about, because lots of people use Premium, very few people use Ultimate as a development environment. Okay. So the idea is then of the fakes library, or the shimming part. There's two parts. The stubbing, which is just standard sort of creating test doubles, which I can inject, like the product repository, something that returns sets of products under my control without having to talk to a database. And then there's shimming, which allows me to essentially rewrite bits of IL of dependent classes at runtime, okay? To do the things I want them to do rather than the things they actually normally would do. And I can change static members, I can change concrete members, okay? We start the process by generating a thing called a fakes assembly, okay? So, as I said, built into Visual Studio as of 2012. Got a bit of code here. So, why can't I unit test this code successfully? Datetime.now, I can, I've got two tests here. So, also, I've got two tests to make sure it does the right thing in morning and afternoon. Unless I'm really, really lucky, both of these tests will never pass at the same time. Yeah? If I ran it about noon, I might just about be able to get them both to pass at the same time. Okay? But generally, obviously, the main thing is you don't want your test to be dependent on the time of day you're running them, or whether that's success or not. So I want both of these tests to pass. The question is, how do I do that? So that's one of the issues is datetime.now. There's another problem as well. Yeah, unless I'm somehow magically monitoring a console window, I have no idea whether this is doing the right thing in terms of output. Okay? Now, what I could do here is I could inject an output service that was in production, was wired onto the console, would allow me to see the output, and I can inject a date provider or a time provider that would have datetime.now injected into it. And in this situation, that's probably what I do. It's not particularly, not a particularly complex bit of code. But it just proves that even fairly simple code can require some, acrobatics to be able to test it. What I want to do is be able to leave the code intact and prove it works. Okay? So I need to change what datetime.now does and what console.writeLine does. Okay? So if we go to the test library here, we've got some references in here. Now the problem is that it's like the actual classes are not remotely under my control that I need to change. They're part of the base class library of .NET. So if I go to the reference here, I can say add fakes assembly. Okay. And then I end up with this sort of bit here where it says two little bits of XML that tell me what types to rewire on my behalf. Okay? Now, if I'm going to change the IL for what datetime.now does, I obviously don't want this to be a permanent change because all my code would stop working properly, okay? So it's obviously going to be temporary. And I need to make sure it gets pulled out when my testers finish running, okay? Back to the normal implementation. So what I do, I create this thing that's called a shims context, okay? It's an iDisposable thing, which at the end of the using block, all the stuff I put in place gets thrown away, okay? Okay, so what I want to do then, okay. So what I need to do now is, obviously I've got the standard pattern of a test, arrange, act, assert, yeah? So I've got my arrange. Around where I'm doing the act, I need to change what is actually going to take place within the dependent bits of code. Now, anyone think of a problem with this approach? There's a couple of issues, but obviously I'm very much tying myself to the exact implementation of what this does at this point, yeah? It's very brittle. Now, it's the only way to do this, but it is completely dependent on exactly what that implementation is doing, okay? And again, it's one of those trade-offs. If you want to introduce unit tests into something without changing the code, then you are going to be reliant on its implementation to make sure the implementation is redirected to do something different, okay? But it's a starting point. I certainly wouldn't recommend this as your general approach to testing. Don't worry about the design of your classes. Just chuck any old hardwire dependencies in and then use shims to sort it out. It's a tool to try and bridge a gap, basically. Okay, so yeah. So now we have this new version of datetime called shim datetime. Okay, now the idea of the shim, it basically has members that said if you provide a delegate, it will rewrite the IL of the actual member to call it. By default, it will just hand off to the real version, but I can change where it points. Now, it's a slightly strange thing called now get. Now, datetime.now is a property, has a getter and a setter. I'm saying I want to change what the getter does. There isn't a setter of datetime.now, as you can probably imagine why. That would be a strange thing to have, like magically changing the time in the world. But I want to change what the actual, what the getter returns, okay? What we're doing this afternoon, I think. So, okay, so, oh, no, that's the morning. 50-50 chance, isn't it? Okay. Okay, so at this point, I've basically said, when datetime.now is called, return that date time, rather the actual date time, okay? So if I go to agree a code. Okay, and then I go and debug my test. The problem with doing conference talks, you don't get much real estate on your machine. Yeah, I very rarely develop it. It's 1024 by 768, I must admit. Okay, so datetime.now is coming out as the date that I specified, 11 o'clock on the 9th, 10th. Okay? So I've rewired what that IL does. Okay? Okay, so nice thing is I can go to my tests and I can do the same thing here. This time it's change it for the afternoon. Okay, so I've solved one of the issues by using a shim, but I've got this other issue. How do I verify what the output is? Okay, so I need to rewire what console.writeLine does. So going on the same basis, what I can do inside here is do shim. And unfortunately, there isn't a shim console. And I think they specifically designed it for conference demos, because the one thing that always gets shimmed is date time, okay? And GUID, nothing else. Okay? Well, this isn't really very useful, is it? It's only shimming. The problem is, how many types are in MS Corelib? Huge number. This faked assembly would be enormous if it automatically did everything. Okay, so I have to tell it which classes to actually shim if I want more than date time and GUID. I don't know why it bothers doing date time and GUID, if, apart from it's easier to do a conference demo. Yeah? Okay, so what we need to do is tell it to produce other shims as well. So this is where we get these two bits in the fakes thing. I can tell it other things that now these things are in MS Corelib. Now notice that generally in a project, if I go and look at references, I don't see MS Corelib in there. Okay? It's just assumed that MS Corelib is where the type system lives. You know, you have a dependency on that whether you like it or not if you're writing .NET code. Okay? It also adds a system assembly in here, so we have to basically say, oh, I want to fake the system assembly, and that will do MS Corelib as well. Okay? You have to know which assembly the types live in to do the shimming correctly. Okay, so here basically we've got this section saying MS Corelib fakes. So I open this up, and then there's shim generation. I wish I got IntelliSense on here. Oh. Okay, it might be shim's generation. I thought it was IntelliSense. Oh, that's a nightmare. Okay. I may have to go to the universal help system at this point. Don't you just hate it? Okay. I can't remember this is right at all. It's something like that. Build failed. Oh, fail. There's no errors. So what are the warnings about? The element cannot contain white space.
The blue squiggle at the top. You have white space there.
Well, that's okay. Maybe it's not inside. Ah, there we go. I could have sworn there was IntelliSense on this. Well, the rest of it appears to be correct. That's surprising. Okay, so hopefully now it's generated me the shim assembly for console write line. Okay, so I've got a shim console now. And you can do it by namespace and rather full type name if you want everything in a particular namespace to be brought in as well. So it doesn't have to, and you can use wildcarding. You can say, I want everything from namespace, but exclude things with this in their type name. So you have a fair amount of control of exactly what gets generated. As I said, you don't want to generate massive shim assemblies just for the sake of bringing in one or two types. Yeah. Now, the problem is, write line has a number of overloads. So I have write line Boolean, write line char, write line. How, because we can only rewire one method. I can't just say rewire write line because there's lots of versions of it. So it gives me a different member based on all the parameters. And so I have to know which version is being called internally, or rewire all of them, okay? Which again adds potential brittleness into your code. But again, if you don't have an option, then you have to do. Now, I'm pretty sure it's calling string version. Format, and then it's passing a string as the name. So I think there's a string version. There's string object. But I'm pretty sure I'm using string object. Maybe that's the one it's using. Is there not a string? Yeah, it can't be a string. So yeah, it must be string object I'm using. Okay, equals. Okay, so format and object goes to get out into full screen mode to get a bit more real estate. So what I need to do then is I need somewhere to capture the string output. And now I can get rid of my assert.inconclusive and do something like string assert.contains my value is output and good morning. So hopefully now, if we make it so it runs when I build, that's not when I create new, when I build. Why does that not run? Ah, there we go. Okay, notice that that's now passed. Okay? So I should be able to do similar sort of job down here. Okay, so I can basically take existing legacy code with dependencies beyond my control, and I can rewire the behavior such that it works. Now, which is a nice trick to be able to do, and it gets you out of some holes, okay? I said it would never be my first, sort of like my starting point to solve problems, but it's a very useful tool to have in your toolbox to get around those problems where there doesn't really seem to be a viable alternative. As you can see, the test is highly dependent on the implementation here, okay? It's also, you may have noticed, it's not massively fast, okay? There's a bunch of work that needs to be done. It's got to change the IL, it's got to re-JIT the MS core lib and stuff like that. There's a whole bunch of different extra work that needs to take place. And there is another issue as well. Oops. I'll come back to that. You can shim statics, which is what I've done. You can shim instance methods. You basically just say, do all instances get this change? So concrete methods on classes, not that aren't statics, can be shimmed as well. You can shim constructors, you can shim static constructors, you can basically anything part of the IL. The syntax is a bit different in different circumstances, but everything is basically rewritable. Remember I was saying that always, inevitably, inside your code, some of the code is going to hit the metal. Yeah? It's going to talk to the config file. It's going to talk directly to the database. At some point, that stuff is actually going to happen. And you say, well, how do I write tests for that stuff? Well, this is one way you can actually test the stuff that hits the metal as well. Okay? So the common thing is to hit the config file to get stuff. At some point, somebody has actually got to write the code that goes to the configuration manager and actually hits it. You can essentially rewire what, for example, the app settings does to produce stuff that isn't actually in the config file, so it doesn't have to talk to the config file, but you can write tests that verify your code behaves correctly depending what's in the config file. Okay? So not just, it's useful for legacy code, but it's actually a useful thing in general for testing that hopefully very thin layer which physically has to talk through a resource as well. Okay? It's not free, though. There's always issues, aren't there? I said one is a bit slow, but there's a fundamental issue that you have to be very aware of. When the IL gets compiled into native code, does anyone know what the scope of that visibility of that compiled code is? Who can see that compiled code, the JIT compiled code? Well, essentially, it's all code in the app domain, the application domain. Okay? Now, unless you do something about it, all of your code will run the same app domain. Okay? Which means all code that is concurrently executing will see the same version of the IL. If you rewire the IL inside your test, then any other test that's running concurrently will see the same IL, okay? Or the same JIT compiled code from the IL. And if all your tests are rewriting that IL differently, then who gets in last wins, okay? So as soon as you start using shims, you cannot run your tests concurrently, okay? And lots of test runners will try and run stuff concurrently because obviously, ideally, tests don't have side effects. Your tests immediately have side effects when you use shims, okay? So you have to turn off concurrent execution of tests if you're going to do this. The annoying thing is you'll probably get lots of tests passing all the time because the likelihood they enter the same bit of code at the same time is less likely, and then suddenly you'll just get sporadic, bizarre failures of tests, okay? So you can't run concurrently. I think you have to turn it on in Visual Studio to run concurrently. I think NUnit Runner by default does run concurrently, though, as far as I remember. So just be careful with that. Okay. So given the opportunity, writing code in the first place so that it's testable, so that dependencies are injected, such that things are replaceable, such that you keep methods small in terms of execution, that sort of thing. You produce visibility of results that are important. at the starting point, that's always the best way to go. Unfortunately, that doesn't help being the best way to go if you have a legacy code base that wasn't written like that. Okay? So, to be able to test legacy code, unless you're going to shim everything, which I said I wouldn't recommend because there are issues in shimming, then you have to change legacy code. The goal is to not cause cascading changes across your application as a result. Okay? And so, whenever you make changes, you change the code towards abstraction and try and always maintain the public API. Sometimes you can't, sometimes you'll break things, and sometimes you have to change more code than ideally you would. But if you can minimize, especially initially, the scope of change, the likelihood you're going to break stuff as you introduce tests into the code is highly reduced. Okay? As I said, there's a number of different techniques you can do to help ease the way with stubborn bits of code that are hard to evolve. And at the end of the day, if you need to, if you've got the pay version of TypeMock or you've got Visual Studio Premium Edition, then at least you can use shimming to replace those bits of code that otherwise you just have no way of working out how to be able to test. Okay? So, any questions? Yeah.
Can you expand? You were talking earlier about asynchronous code testing. Is this an option that you might suggest whereby the tasks are simply used to verify that it's all appropriate level?
Okay, so asynchronous testing, would I recommend tasks in general to, if you're writing stuff that runs asynchronously and you want to unit test it, you have a fundamental problem, essentially, that your test has to be able to wait until the asynchronous thing is completed to be able to verify its outcome. There are ways of doing it. You can, essentially, you could use a strategy pattern. You can pass into the method a strategy that it executes, and inside that code, you basically block, yeah, and then you wait on the synchronization primitive to then verify the outcome. But the simplest way is to design the code in the first place so that it signals a task when it's done the job asynchronously. And the vast majority of your code will probably never use that, although it does come surprisingly useful. But to actually get you having the testers wait on that task that signals when the operation is complete is by far the best way to go if you have sort of the freedom to essentially control exactly what the code looks like. I was writing, if you're familiar with the task infrastructure, I was writing a task scheduler the other day. And the task scheduler doesn't allow you to do that. And so you don't have control over the internals of what's happening. You basically write a wrapper around their abstraction, essentially. And you have to use other means. But if you are in full control and you're doing asynchronous things, I really would recommend creating a task that models the end of that execution. It doesn't really cost you anything in terms of execution speed, but it makes testing so much easier. The other thing you end up doing, which always seems like a good idea when you first start, is putting thread.sleep in your test. Okay? You'll think, oh, I'm only doing it in this one place. It'll be fine. The problem is then you've got like 20 tests which are all sleeping in different patterns, and the whole thing just gets horribly, horribly messy. Okay, so if ever you find yourself doing thread.sleep in your test, it's one of those nasty, nasty. There's something you should really have to refactor the code to make it obvious that the asynchronous thing is completed. You know, I'm not saying you never, ever end up in a situation like that, but it should be incredibly rare you end up in a situation like that. Yeah.
But shouldn't asynchronous code, I mean, if you're testing going into asynchronous code with aggregate, aren't you now working at more of an integration level of testing? Can't you argue that unit tests should be working down at the function level anyway?
Well, the asynchronous code may simply be, obviously, with, for example, UI-based code that calls out to a dependency. Maybe it's normally going to a network. The last thing you want to do is do that synchronously, yeah? The question is, you know it's going to call out asynchronously, but how do you verify it's actually made the call correctly? Because it's going to do it asynchronously. You can't, you know, your test will finish and the asynchronous call may or may not have happened. Yeah, you need to verify it's happened, especially with the introduction of the async and await key, which makes it much easier to write the asynchronous code, but makes it harder and harder to test because your test code will finish before the asynchronous stuff takes place. And And the annoying thing is, it looks like your test worked because it just runs out without anything going wrong. And so you think, oh, that was fine, that was fine, without actually realizing you haven't actually tested the thing. So I know what you mean in terms of some asynchronous stuff that, especially if it's doing background processing, sort of like long-running background processing, you're absolutely right, that's more of an integration test. But if you're doing stuff asynchronously that is really about keeping a UI responsive, then, and you just want to prove that it called into the network resource, but the call is actually being performed asynchronously, then it's really still a unit test. But how do you verify the actual thing has happened before you try and assert the outcome? Okay, yeah.
Do you know of any similar frameworks to Microsoft Fake for Java?
Oh, no, I don't. I'd be stunned if they didn't exist, though, because Java bytecode and IL are just, twins in the sort of managed execution world. So it's, perfectly achievable. So I'd be stunned if they haven't done it. And Microsoft had to get the idea from somewhere. So, I mean, that was innovation. So yeah, I'm almost certain, but I'm off the top of my head. I mean, does anyone else know about that in the Java world? I said I'd be stunned because of all the AOP frameworks and stuff like that exist in the Java world. I'd be stunned if it wasn't there, but off the top of my head, I'm afraid I don't know. Yeah.
So I have a large legacy system, and I now want to begin to get unit tests into it. So I go to my management and say, I want to put unit tests in, and it's going to cost us this much per class, and I've got this many classes. And management say, okay, why do you want to do this? Why do I want to do this? Say I've got regression tests that already show, integration tests that already show that the software fundamentally works.
Yeah, and I guess what is the goal of unit testing? It's really not about proving the regression tests work. It's about, during development, it's trying to speed up the development to say, I know that I haven't broken stuff, so we don't find it in UAT. We find it at the point when I'm doing the build, or I check in and stuff like that, is that we find out whether the thing's broken and we fix it at that point. We catch things earlier, and so we don't have to do that nasty cycle of deploying to UAT. They find the test, they send us back the test results, and we then do and resubmit. If we can find stuff earlier, it speeds up the development. It makes the actual test. If there's one thing that testers hate more than anything else, it's when they report a bug that you fix that introduces a whole bunch of other bugs, that all stuff that was previously working. And it's like, particularly if testers don't come from a development background, because they go, why has this happened? All I asked you to do was fix this, and all this other stuff that was working doesn't work anymore, without obviously without understanding the nature of how writing code works, and that actually that's quite a feasible thing for you to do, is to break stuff when you fix other things. But and also it means that that level of confidence that people get that the number of bugs decreases over time, and new ones are very rarely appearing that were previously working. Management, you're right, have to buy into this because there is a cost involved in doing it, but it's about long-term manageability and the ability to change and affect business change on a fairly rapid timescale, hopefully without large sort of damaging effects through doing it. I think that's what it gives them, but it's not free, that's for sure. Yeah. Okay, so it's 5 to 1. If you run, you'll be first out to lunch. Okay? Thank you very much.